So in the past, I've talked about standing pilot furnaces that had a pilot light burning all the time, and we talked about direct ignition, where we lit the main burners directly. This furnace is what we call an intermittent pilot system. It's still an 80% gas furnace, but instead of having that pilot light burn all the time, we simply light the pilot specifically before we light those main burners. So the sequence of operation of this furnace is a little bit different. The thermostat is going to call for heat, connecting R and W, send 24 volts to the IFC. The IFC is going to do a quick safety check. The IFC is going to energize our inducer fan motor. This inducer fan motor is going to pull a draft through the heat exchanger. So as that fan motor is working, it's pulling a draft through the heat exchanger, making sure it's clean and clear before we have an actual ignition system. Once this pulls a vacuum, it closes the pressure switch. The vacuum pulls the pressure switch closed. The pressure switch sends 20 volts to the IFC, ensuring the IFC that, hey, we are working safely, this motor is running, we have the proper vacuum. Then the IFC sends a signal to the combination gas valve. The combination gas valve then opens this little bitty pilot solenoid and allows gas to flow through the pilot tube. It also energizes a miniature hot surface igniter. And we're going to show that here shortly. We're going to take all this apart. That hot surface igniter ignites the pilot light. There's a miniature flame sensor back here that's going to prove a flame through flame rectification. Once that's proven, this valve is going to open the main solenoid, allow gas to flow through the manifold, to the spud, through the orifice, mixing with primary air in the jets or the burners, across that pilot light, igniting into a flame that's going to be burning inside of our heat exchanger. The flame is going to be burning in this section of the heat exchanger, which is our combustion area. Then it's going to be the hot gases traveling all the way out, being pulled by that inducer fan motor. The IFC is going to let this heat exchanger heat up. Then the IFC is going to energize our main blower, allowing us to move air across this heat exchanger and putting that heat into the house. So that intermittent pilot is going to be burning all the time while it's running. But when the system cycles off, we're also going to shut off that pilot. So what's going to happen is the house heats up, thermostat satisfies, it's going to break the R and W. The IFC is going to immediately kill the signal for our combination gas valve. It's going to shut off the main burners and also the pilot. So all the gas is 100% shut off. It's going to continue to run our inducer fan motor to post-purge, clean out that heat exchanger, and it's going to then let the main blower run to cool off the heat exchanger and then cycle it off. That's going to be our system of operation. Now, this particular combination gas valve has a special name. They're called smart valves. There's two different manufacturers that made them, Honeywell and White Rogers, but both these worked very similar. There was different modifications and times with them, but they required a little different steps for servicing them and diagnosing. We had our main IFC, plus also behind here there's another little control board in this as well. So they make this little cool tool that you can hook up, you can plug in, and you had many different options for what size you need. And so you would match up the model number of the gas valve to one of these little cards. In this case, this is a valve SV950. So we're just going to slide this little card inside of here. And then we have to find the right plug adapter. So this little plug adapter is going to fit onto the top section. And it's got this nice handy little hook, so I can just hook it here next to the furnace. Now I have to put this in series on the system. So I have these two plugs. So I find that plug right here, and I just unplug it. This is the igniter, and what I'm going to do is put this fitting into my valve, and then my igniter is going to plug into this component here. I have another plug. It's this little square terminal back here, and I'm going to unplug it as well. And with this little square terminal, we're going to plug it in to my component, my meter. And then I'm going to plug this last one back into the smart valve. And then have to make sure that I have my ground hooked up as well. So I'll hook the ground up. Never ready to have a call for heat, so we can actually go through the process, and this cord is going to tell us if we have 24 volt power. It's going to tell us if we have the correct polarity, if we have ignition, if our main valve ignites, and if we have our main fan motor running. This is an older model, so it's very simple as what it provides, but some of the other models will go through and provide us with a whole lot more options, including they'll give us the reading for our flame sensor. So I've already jumpered R to W, so the thermostat calls for heat, it connects R and W. I've already jumpered that with this jumper here. So now as I close this door safety switch, we're going to start our sequence of operation for this gas furnace. Now this furnace is designed for natural gas. I do not have any gas here at this building, so I have it modified on propane, so it will not run right. It's actually dangerous to do. Don't run it at home. Also, I don't have my flue pipe hooked up. I have a big vent fan set up to get the carbon monoxide out of the way, but that's also quite dangerous. We're just going to run this for a short period of time so you can see the operation of this furnace. So we're going to have our call for heat. Inducer fan first. Pull it back into the pressure switch. We lit our pilot light. We're going to show this shortly at a close-up. Now the pilot light, we lit the main valve. And if we look on our little control right here, it's telling us that our flame sensor is 1.06, 1.08, and we have proper polarity. We have our igniter, we have our main valve, and it's about to turn the blower on. That last little light's going to come on here shortly. I can feel the heat from the heat exchanger already because I have the side cut off. Once this heat exchanger gets warm enough, now anytime you're working with any gas furnace, you always want to stand to the side and then look in there once it starts up, but you never want to look into the front when it first starts. Those flames can roll out and they can burn your eyebrows, burn your beard, burn your hair, or worse, burn your eyes. So you want to make sure you're always standing to the side. IFC should bring the blower on, which is quite unusual. It should have already kicked on by now. We're going to go ahead and end our call for heat, so I'm just going to pull my jumper off. Pull the jumper off, notice that the flames immediately shut off. But this inducer fan motor kept running for just a little while to post-purge, to clean out the heat exchanger. And we do have some kind of an issue because the blower in this system never did cut on. So I'm going to manually jump that out to cool this heat exchanger off for safety. And we can see that all of our lights ended, except we still have 24 volt power and polarity. So I'm going to turn the fan to the on position, connecting R and G. Now when I energize my door safety switch, our fan motor itself should come on, and now I'm moving air across my heat exchanger, cooling it down. Significant amount of heat coming off, as well as a whole lot of dust from this unit. We're going to let this cool off, and we're going to go back through and check a few more little components. Okay, here we're zoomed in so you can see some of these components. This is our main burner assembly, so we have our spuds and our orifice is going to be right down here, and our manifold is here. So the manifold delivers gas to this component called the spud, and the end of that spud is a hole called an orifice, so it shoots the gas into the center of this in-shot burner. We just simply call them jets. It mixes with primary air. The air is being pulled in here, so the burner's job is to mix the air into fuel. It's going to go across the pilot, igniting into a flame that's burning inside of this heat exchanger. So these little burners, they also have little crossover tubes right here. So as this main burner lights, you're going to see another flame here and here. It happens instantly, but we ignite the burners all the way across. Now right inside of here is where we're going to have our intermittent pilot assembly. So the pilot assembly that's going to be burning is right here. We also have, which I'm not going to touch, right down low is a little miniature hot surface igniter. Then we have over here, we're going to have a flame sensor, and then also the guard, which the flame sensor burns against for the flame rectification. On this side we have our smart tester. It's saying that we have 24 volt power, we have the correct polarity, there is no igniter, no main valve, and we don't have any call for heating. There's no operating control. So what I'm going to do is have the thermostat call for heat connecting R and W. So I'm going to manually connect R to W. Our inducer fan energizes, pulls it back into our pressure switch. We hear a little bit of gas. We see the pilot light burning right there. Now we ignite the main burners all the way across. Now the color of these flames is improper because it's burning on the wrong gas, the wrong pressure, and the wrong orifices. But you can still see that the flames are burning inside of the heat exchanger, and you can see how the crossover tube ignites. The pilot over here is still burning. We did have to remove the safety plate to get the view in. On this side, we can see that the igniter had gone off. We have our main valve open, and this is giving us our flame sensor, so how many microamps that we're pulling. And once the flame sensor, once the furnace heats up, the IFC should bring the blower on, but this IFC is not working correctly. So I'm going to end the call for heat by removing R and W. We can see that everything shuts off immediately. You can also see that our red light came on saying that we do not have our call for heat. So that's our system. It's pretty simple, it's pretty basic. This particular unit has these diffusers inside the heat exchanger, and you'll see that more on propane systems, but it's designed to spread the flame out and just transfer heat better. It's just some of the different technologies that were used. So while we're on this, let's also point out a few other little things. So this is our intermittent combination gas valve. Here is the limit switch. It's actually a flame rollout. This one is manual reset. It was on the plate that I took off so that we could get down here to the components so you can see the burners. There's also another one of these. There's another one of these flame rollouts here on the side and again on the other side. So if the flame rolls out, this limit trips and it shuts it off, and you have to manually come out and press the button to reset it. You don't just reset those, you always want to know why. And in the back right here, this is our primary limit. If we were to take these two screws out, pull this out, you would see right inside of the furnace between the heat exchangers. So if this main limit trips, if it's opening for whatever reason, you have an airflow problem. Either the blower's in the wrong speed, dirty evaporator coil, too many vents shut off, anything you can think of with not having enough airflow behind that unit. The top side here is our inducer fan motor. This is replaced as an assembly. We're going to pull this off shortly, but this motor and this assembly all connects together and it pulls the draft through the heat exchanger. On the side here is our vacuum pressure switch or negative pressure switch. The inducer fan motor pulls a draft through the heat exchanger, negative pressure. It's also pulling a draft through this tube to our pressure switch. It's normally open. These two wires close. When there is a call for, when this fan is running, it pulls a vacuum and the switch closes. So next I want to focus in on this combination gas valve. This is one of the earlier models of the smart valve, but it still works the same way. This port here is also the same side as our inlet gas pressure. So we could actually put a manometer here. We'd shut our gas off. We could put a manometer here to see if we had the correct gas pressure coming into this system. Also, if we notice on the back side of this, there's two different screws right there in the back side. We take that cap off, and behind that's the adjustment for a gas pressure for a manifold, and this is adjustment for the gas pressure for the pilot, for the intermittent pilot. On the other side, we're going to move our little meter out of the way. You can see our pilot tube that's coming out, as well as we have another port right here. This port is going to be for our manifold pressure. We take that port out, we can put an adapter in there and read the manifold pressure. This should be at 3.5 inches of water column for this gas furnace, which is noted on the combination gas valve. Actually, I stand corrected. This one is 3.2 inches of water column as a range between 3 to 5. So this is where we're going to set the manifold gas pressure. This is our pilot tube. Now if we want to shut the furnace off, something's malfunctioning, not working right, we can turn this to the off position. Or if we need to order parts or whatever, we can shut this off. But I also like to unplug one of these wires if I have to do that so the furnace doesn't accidentally come back on. If we have a bad heat exchanger, we can shut this furnace off, put a red tag on there. If the customer decides to turn it back on themselves, that's on them. But we also have them sign a waiver before we leave. So this is our inducer fan assembly. What we're going to do is we're going to pull this off so we can talk about the components, starting with this little hose right here. This is the hose, the vacuum hose to the negative pressure switch or vacuum pressure switch. These hoses get brittle and cracked over time and have to be replaced. This one is fairly cracked and there's a rust, pretty bad rust on the side. Once I pull this off, you can see it. We have 4 screws holding this entire assembly on. We're going to pull these screws out right now. You can see these screws are significantly long. And now we have our blower. So we have also this ground screw, and I'm going to take this screw off so I can move this around easier. So this is our inducer draft assembly. It's just a simple motor. There is no capacitor in this particular one. And we also have the tag on this motor. Some pretty important information here, mainly being the amp draw of this motor. It's rated for 1.5 amps. So what I do is I'd clamp my meter around one of these wires and check the amp draw while it's working. If it's pulling more than 1.5 amps, we know that we have some kind of an issue going on. Other than that, we replace these as an assembly by the model number and serial number on the unit. We order it back from the manufacturer. Even though you could theoretically order just this motor, trying to replace it inside of this housing is not an easy thing to do. Also, very specifically, this hole on the sides of here is for a very tight tolerance of how much air it can pull in. And when I took this motor off, there's also this little bracket fell out. This bracket is an adapter on here so that it gives a even more precise hole. So if I were to put this back together and not have this bracket in there, I could change the airflow, which would change the air-fuel mixture. Notice also this material here is a gasket material. It's a high temperature fiberglass gasket material. So if I was to take this off, I would have to replace that gasket material before I'd put it back on. And you can see also how it's another gasket here on this side. And you see this burnt mark on here. I don't think the gasket was installed correctly to begin with. Also, if we look inside, we can see a significant amount of rust on this blower wheel. And it's just from age. There's a lot of carbon built up. It probably wasn't running with the right gas pressure. It probably never had a combustion analysis done on it. Here, if we look into the very end of this, you can see also a significant amount of that rust that's in there, as well as rust here building up on the side. And this is where the vacuum port hooked up. And you notice there's a lot of rust there as well. Sometimes these will rust up and they will actually stop up the hose, so the pressure switch never even senses the vacuum. But this is our inducer fan assembly. This component here has its own name as well. It is the collector, the draft hood collector. So all of the individual furnace components or furnace heat exchangers are going to collect together in this one little chamber. Then the inducer fan is able to pull a draft equally between all of these heat exchangers. So once we pull this off, you can see exactly what it looks like behind it and the individual heat exchangers. Now as we take this collector box off, you notice it also has its gasket material on it as well that seals it up. You can see there's a significant amount of rust built up on this side, and there's a lot of corrosion in here. This was a horizontal furnace, so this was the bottom side. So this furnace, this heat exchanger side here, I wouldn't be surprised if there's not a hole in it. This side looks in really good shape. As we pull this heat exchanger out, we'll get a better look. These screws here actually hold the heat exchanger to this panel, but this is the individual heat exchangers. Any air from inside of here is separate from the air in the house. As we continue on our path of destruction of this furnace, we're going to look at our pressure switch specifically, and this uses a Phillips screwdriver at the top. So this is our pressure switch. It's a very simple, it's just a micro switch here. It's NO, normally open. So we have our 24 volts comes here. When we pull a vacuum to this switch, the diaphragm pulls the switch closed, and this wire connects that wire. 24 volts returns to the IFC. We know it's working. These are all for different size pressures. If I read on this one, it's 0.65 inches water column pressure factor. So it's a negative pressure. So what we'd actually do is we could put a T in this hose or unplug the hose itself entirely. But notice this one's stuck really good. It's been there a long time. And I have a T adapter that I put here and to a magnet helix to this component. And as that inducer fan motor runs, I can check to see if I'm getting enough vacuum for the switch to close. It's a very simple component, just simply 2 wires, 1 hose, and 2 screws. Sometimes these will go bad if the furnace is leaning the wrong way and you get moisture in here, which is a whole nother issue, but they'll also go bad over time. That little diaphragm that moves around back and forth in here can start to crack and break over time. But you can simply check it by using a manometer, see if it's actually closing or not, getting the right vacuum to it. Next, I'm going to try to take this assembly out as one piece so we can look at it, and then we can take it apart individually. There should be 4 screws holding this on. We'll see if that's correct. If you notice this burnt spot here, this is where the pilot light has been burning up against this shield. This shield goes against the back. I've already taken the shield off across the top that protects the burners so that we could get the video. Now we can get this almost as one full set. But we have one set of wires right here, and this is what I want to point out. This is our primary limit switch. So I'm going to go ahead and undo the wires for that as well. This limit is going to trip because of overheating by airflow. So if this switch is tripping on you, you need to be thinking immediately airflow, airflow, airflow. For some reason, so many new techs keep thinking that it's a gas problem or it's overheating because there's too much fuel in there, and that's not true. It is going to be an airflow issue. Now these are automatic resets, and there's this one I can't manually press it in, but this gets too hot, it opens the limit. And this one may or may not say the reading on it. It's hard to see it on here, but it should say the limit that it closes and how many degrees before it opens back again, or vice versa. If you look through this hole here, it's right between the heat exchangers. It's not on the metal itself, it's right between it. So if the airflow stops going, this is going to radiate heat out of both sides to the limit, and then this limit opens. So what we have is this whole assembly out. Let me rearrange this so we can get a better view of it. So here we have our burners pulled out from the gas furnace so we can see everything. Now what you're looking at is the side that faces the furnace, the side that faces the heat exchanger. So now we can get a good look at everything. Here we have our main limit switch. This is going to be what's sensing for the air. Here we have our flame rollout, another flame rollout, and these 2 wires here, they go to a flame rollout on this side here. So if the flame was to roll out of the heat exchanger back this direction, those limits would shut off. Remember again, those limits are manual reset. So if we see on the side, there's a little button right there, and you can press that button to reset it. Now never just press that button, find out why, what's going on with it. So this is our smart valve, our combination gas valve, and we have our manifold here. On the back side you can't see it, but you have your spuds and your burners. These are the burners, in-shot burners, also called jets. Now if you can see right here, there's all of this corrosion on here. So these are 2 things that worry me. One is thinking it hasn't been serviced, but the other thing I'm thinking is there an issue with our gas pressure? Was it never set up right? So I think that's probably most likely the issue, that this gas wasn't burning correctly, wasn't mixing correctly, and we end up with all this soot on here. Now what we want to focus on next is this part right here. This is going to be our intermittent pilot. This is going to be the thing that really makes this furnace come together. So I'm going to readjust the camera so we can get a better look. So in our burners, we were talking about earlier these crossover tubes. You can see this little split right here. This allows it, once we ignite our burners, it allows it to go across through to the next burner, ignite it, and so on. So these are little crossovers, but this section right here is our intermittent pilot assembly. Here we have our pilot tube. Inside of here is going to be an orifice just for the pilot, and this is the pilot burner. It directs how that flame is going to burn. Right here is our miniature hot surface igniter, and right here, this little bitty rod is our flame sensor. It's our miniature flame sensor, and then this is our ground part here. So when the pilot's burning, it's burning across that flame sensor, and that flame sensor, it allows it to have flame rectification. In other words, the flame becomes a switch, and as the flame conducts electricity through this rod to the ground, it makes it go into a pulsating DC signal that's quite unique that the control board reads. So we're going to plug this furnace in. I got it wired up to where we can see the hot surface igniter happen. Now I can't have it to where the pilot lights, because if the pilot lights, then the main burners would light right afterwards, and that would burn up the camera, and I would be in a little bit of trouble. So we're going to go through a sequence of operation, have the thermostat call for heat, connect R to W. Inducer fan runs, pull the vacuum to the pressure switch. Now we can see that hot surface igniter getting hot. It's turning bright red, and it gets so hot that we should be able to touch a piece of paper to that, and it just instantly catches it on fire. So it is a hot surface igniter. Now these are very fragile. If you look at these wrong, they break. So you got to be very, very careful if you're working on this type of a furnace. This little hot surface igniter is extremely sensitive, so I make it a point to not touch them, to not really mess with them. So these hot surface igniters right here are really, really fragile. I make it a point to not touch them because any little bit of pressure you put on there, that little bitty resistive material breaks so easily. So in the past, we would try to clean these flame sensors. We had to be very, very careful cleaning that flame sensor that you didn't even touch that hot surface igniter because it would break all the time. So it was very difficult cleaning these flame rods. So I always hated it because you had to clean the flame rod, but you also had to stay away from this. So this is the flame rod, and you can see there's this discoloration on there. So this is definitely getting dirty, and we would have to clean this up, and we'd have to use something like a type of Brillo pad, but we'd never use sandpaper because sandpaper would gouge this, and the sand on the sandpaper would leave a coating which would cause this to have a type of glass coating and not work very well. This whole little assembly, see this little piece right here, will actually unscrew, it will pop out separate, and we can replace the hot surface igniter and the flame sensor. It includes the wires and the plug for the combination gas valve as an entire kit. I used to keep these on my service van, and when I come across these broken, we would replace them. Typically these lasted about 5 years in general, but sometimes they last a lot longer and sometimes not nearly as long. If you were to touch this with your fingers, sometimes it would leave an oil stain on there which would cause them to break out even faster. Also, dirt in the system would cause these to fail also. So this is our intermittent pilot system. For what it's worth, hopefully you're not going to run into these much in the field anymore, but there's still a ton of these out there. So next we're going to go back to a few more little components here I want to break out, such as, so from this angle we can see our combination gas valve, or what they called smart valve. This is our dial where we had off and on. So if we wanted to leave it in the on position, we would have to turn this dial so that way everything could actually light up. This plug right here is the plug for our hot surface igniter and flame sensor. So the two blue wires is for a hot surface igniter, the single wire is for a flame sensor. And there's simply a little plug on the side, little keeper. We push this keeper in, and this just unplugs, and we could replace that. On this side here, this is our incoming, where a gas line would come into this. And right here, you see this little shiny port. If I was to use my screwdriver here, we could unscrew this port. And this allows us to get to our adjustment for our gas pressure. Remember, this is a combination gas valve, a combination of a gas valve and a pressure regulator. So if we zoom in here, you can see this component right here is what we'd use to adjust the gas pressure. You would put it in that plastic piece, and if you screwed it in, it would increase gas pressure, and if you backed it out, it would decrease the gas pressure. On the side port here, that was usually for our pilot assembly, so we could adjust the flame on our pilot assembly. Also, you see here it has our PSI. This is our inlet. This is the adapter where we can check the gas pressure coming into the gas furnace, and we want to check that static and while it's working. We have a tool that we use for that. It's the same tool we use for AC. It's our service wrench, and that same adapter fits into that, and we'd set this to be loosened. This is the plug that comes out, and what we have with this would be open. So if the gas was on while I did this, gas would be pouring out. So you'd have to shut the gas off. You would put in this little adapter right here. Once you have your adapter, you could put your hose on this to your manometer, turn the gas back on, and you could check your gas pressure. Then you started the system up, you could see what your incoming gas pressure was. Sometimes we'd have a furnace that would be running fine by itself, but if the water heater or stove was running, we wouldn't have enough gas pressure coming into this system. We'd have to remember to shut the gas off, and then we would take this piece back out, and then we would have to put this port back in where it was, otherwise we'd have gas leaking out. On the other side is where we see our output port. So this port right here is very similar to what we saw earlier. This port is going to be the manifold pressure. So the manifold is coming out on this side. We would unscrew that with the same exact tool. We'd put the same adapter in there, and this way when the combination gas valve opened, we would see what the pressure was in the manifold. So this port is giving us the same pressure that's in this manifold. On the back side, we also see this tube right here. This is our pilot tube. So this is what's sending gas to that intermittent pilot. And then on the side as well, this is what's going to our control board. So the control board communicates to this, and it's just simply a square plug. We have a little keeper on it as well. If I just press that little keeper, this unplugs, and we have the 4 wires on this. So it's quite a simple little control, but inside of here is also a separate control board. Just plug this back in. It was very important when you did maintenance, you had to make sure that you put this plug back in, that you put this plug back in, and also you didn't lose the little cap for the pressure regulator. So this cap had to be on, otherwise you could be leaking gas out of this port right here. It was also important that when you left the customer, before you left the customer's house, you had to use a gas leak detector, an electronic leak detector, or you would use soap bubbles or both to make sure it wasn't leaking. What I used was an electronic leak detector, and I would have it running the whole time I did service work. So my electronic leak detector would look something like this right here, and it had this end piece on it, and it was just a sniffer. It's flexible end, and when I turned this on, I would sniff all of the components with this tool and smell for any kind of a gas leak. Soap bubbles has worked as well. You can put the soap bubbles around there, but you want to make sure you use a specific type, because regular plain kitchen soap could have a corrosive effect on some of this aluminum. So you had to make sure you use a specific gas leak detector set up for natural gas, designed for that, and all the supply houses carry that. So when we talked about this smart valve that had a control module on the unit and another control board inside the valve itself, at the time I didn't understand how that works, so I bought this tool a long time ago and spent a lot of money on it, as well as other adapters for other units. But when I got to reading more and started learning the importance of reading, the book actually has tons of information about how to diagnose and how to check these components without having to have this expensive piece. So I recommend you start getting into reading, learning about how this stuff works. These videos are a great way to start, but there's so much information in these books. That's where this one's at, and tons of stuff you can learn from. And keep reading. I'm not somebody that likes reading myself, but as I start learning and looking for information, referencing information, I always learn more as I go through these books. So next we're going to go through more of this furnace and take more stuff apart. This is the door that's on the blower section of this furnace. Notice it's solid, so it's not supposed to pull any air in from the combustion area. It's got a lot of little safety components on here, how to operate the valves. It's got a lot of warnings: improper installation, adjustment or altercation, service repair, operation, maintenance can cause bodily injury, property damage, or death, such as fire, explosion, smoke, soot, condensation, electrical shock, carbon monoxide. Refer to the installation instructions. There's so much information in here. Having this door on, people overlook it so much, but this door is a key part of making sure that furnace is safe. And that's why we have this door safety switch, also called a door interlock. Now, see, a lot of times when people are working on this furnace, they'll take and put tape on this to hold it in so they can do their checklist. I have a magnet that's on an angle that doesn't work for this one because there's not a great way for it to hold onto. So there's two ways. Either you can hold the switch in and do your service work, or you can tape the door switch. Now, I am against taping the door switch. I don't like doing that, and the reason is people put the tape on there and they leave the tape on there. So my solution to that is, if any of my people are taping the door switch, I have them tape their car keys, their van keys, tape it to that switch. Now, when your van keys are taped here, you know that, hey, before I can go to the van, before I can leave, I have to take the tape off to get my keys to take it with me, so you won't accidentally forget. People tape this with good intentions of taking it off, but they forget. Now imagine this door switch is taped closed. The customer opens this to change the filter, leaves the door off. Now they get combustion gases coming in. Well, you've bypassed the safety, you're liable. So that door safety switch is very important, as well as the door itself. I've already taken these two screws out, and now we're just down to the last little bit of electrical for the system, which is the transformer, we have the IFC, the blower, the capacitor. All of this is cool though because it's all mounted on these nice little tracks. So I can actually slide this whole entire assembly out of the unit. So I can pull this out of the house and work on it. So that's what we're going to do next. We're going to slide this thing completely out. We're going to push the furnace out of the way, which is a luxury we don't get to do in the field. So we have this furnace out where we can see all the components. I'm going to start with the door safety switch or door interlock so we can get a better look at it. 2 screws, this comes off, and all the power, the wires coming in from up top, the hot wire comes from the pigtail down into the switch, out of the switch, and then it goes to the control board to power everything else. But this is our door safety switch. It's a simple little component, and they're notoriously for this plastic piece breaking. If it breaks off, we replace it. Only 2 wires, and these little clips press in, and when you press these pieces in, and this one, they get a little old after a while from the plastic getting brittle, but you can push this out. I'm going to need my pliers to grab both of these at the same time, but this pushes right out, and we can slap a new switch right in there. Never leave a unit with a bad door safety switch. It's simple to replace. Now, another thing I want to point out is our transformer. This transformer has been replaced, which means there was a short in the system at some point in time. A transformer never goes bad without a short, so something had to have shorted it out. So somebody's replaced this transformer, and it's a universal, which is why we have an extra wire. But what I see here is absolutely horrifying. There is duct tape used to hold these wires on. And that's right, duct tape. So I'm curious to see what's behind the duct tape, what kind of connection they used. So we're going to go ahead and pull these wires off, this tape off, and see what the wire looks like. And oh my gosh, this is scary. So all they did is took the raw wire from the new transformer. They left the plug that was on the old transformer, and they just shoved it inside and taped it up. That is absolutely horrific. You can see how brittle this tape is. It's really surprising that the tape hadn't caught on fire. And they should have put a fuse in. Anytime that you change out a transformer, you always add a fuse on the low voltage side. So where the yellow wire was here, I would have put a fuse in line there. Another thing I would have done is put a male terminal here, so that way the female terminal would have slipped into the same exact wiring harness. It doesn't take that much extra work to put the system back like it should be. So this is our primary side, our high voltage side. We'll pull this off. It just absolutely horrifies me. I've seen a lot of stuff, first time I've seen that. So this is our primary high voltage side. In this case, we're using these 2 wires, which is common and 110 volts. And then if what other voltages that we used would be these other 2 wires, one of which with common. We'll look at that in the electrical class. Secondary side here is our low voltage wires. This goes as what we call secondary. So we're going to cut the cable tie off of these units so we can see this wiring better. Just going to take and cut that off. And here, these are going to be the wires going to the motor, just for the blower motor. So here we can see this blue wire is on a tap called unused. So that means this speed of the motor is not being used at all. Now we look at another wire. We have here the red wire. So let's see where the red wire goes on the control board. And it's going to be hard to see. Let's pick another wire. We have this white wire, which should be our neutrals. And if we look over here, it goes to terminal number 4, and all of these are with the other white wires. And you won't be able to see it right just yet, but it says neutral on this control board. So that's our neutral. And then we have this black and red wire. So let's see if we can move these wires out of the way to see where they go. And let's see if we can focus in. The black wire is going to where it says cool, and the red wire is going to heat. So the red wire is the speed that's energized when we have a call for heating, and the black wire is when we have a call for cooling or fan only. So once they unplug those wires, our fan motor is completely separate. Let's see if we can see the cool terminal and also the heating terminal right there. So that's all it is for the fan motor. And you can see here's the wires going to the motor itself. Now another thing going to the motor is our capacitor wires. And our capacitor wire is going right here. So we'll just take this one screw out on the side. And it's So this is the wiring here for our motor. The wires that are left over go to all the controls. This plug goes up to the top side of the cabinet for a limit switch, our combination gas valve or smart valve, and all these other components are just for our control board. And I want to show you a few more things in this control board. Here we have, it says fan speed delay off adjustment. So these are our dip switches. So the different patterns, if I have them both down, which like it is now, it has an off delay of 60 seconds. So that means after the flames end, the blower stays on for 60 seconds. What's more efficient is if I was to push one of these forwards. If I moved this terminal forward, now it has a 90-second off delay. And another thing, if I wanted even more heat out of that, I would push where this one was up and this one was down. That'd give me a 120-second off delay. And if they were both all the way forward, that'd give me a 150-second off delay. So this would make it more efficient. I'm getting every little bit of heat out of that heat exchanger that I put into it with the gas. The problem with the 150-second off delay is it's going to be pretty close to room temperature air. And room temperature air moving is going to feel cooler. So the customers would complain, hey, it feels like it's blowing cold air. That's why they give you these adjustments that you can change the off delay. In this case, a 60-second off delay, there's still a lot of heat left in the heat exchanger, but also warm air is still blowing out. If we had a humidifier accessory installed, we could install it between this terminal and also neutral over here. If we had an EAC, electronic air cleaner, we'd put it between this terminal and also neutral over here. So humidifier and neutral, electronic air cleaner and neutral. These are all covered up. We're not using those terminals right now. The low voltage wires for our transformer, if we were to trace them, they go all the way over here to the side, and it says C and X. So I'm going to pull these wires loose. So we have C and X, and right between them it says XFMR. That's a pretty common abbreviation for XFMR being transformer. So we're going to put those wires back. The neutral wires for our transformer will be over here, and the hot wire, the black wire for a transformer, if we follow this wire, physically push and follow it, it goes over here on the very top side, and it's just marked terminal number 2, so it doesn't give us any specification of exactly what it's doing or the purpose it's there. This blue wire is coming from our door safety switch, and that's also our main power wire. And all we have left is this terminal called D1. Not exactly sure what D1 goes to, so let's follow the wire and see where it goes. And it looks like D1 is going back into our plug, and D1 is going to be powering our inducer fan motor, and one of these will be common going back to it, or neutral going back to it. So our control board is pretty simple. The only thing we haven't talked about is these wires. We have C, 24 volt common, G, indoor fan relay, Y, cooling compressor contactor, W, indoor heat, and R, 24 volt power. So here's the thermostat wires that were left. And what's important is to know what the letters mean. So when I have a call for heat, the thermostat connects the R to the W. So when I jumpered it, I put a jumper between R and W. Now W stands for heat, doesn't stand for white. Notice over here, common is also a white wire. So if you just put all the wires together by color, you could actually cause a short by putting those in the wrong location. So very important. Also, they used for Y, they used blue wires. Perfectly fine. So Y is blue, not yellow. Don't get hung up on the colors. Make sure you connect R from this unit to R at the thermostat. Make sure W from the unit connects to W at the thermostat. Make sure Y from the thermostat connects to this Y terminal and also connects to the Y terminal at the compressor contactor outside. The G terminal goes to the G terminal of the thermostat, and the C terminal goes to the C terminal of the thermostat and the common side of the compressor contactor outside. So we can then, now that we've got those wires separate, undo these 4 screws. And we can clip this little cable tie off to the side. And we're going to turn the whole motor assembly around. And we see on the very opposite end, we have a sensor right here. If I turn it, we can now see this sensor. This sensor is an auxiliary limit switch. It's going to protect it from overheating. So say this fan motor stopped working, the primary limit failed, the heat's going to keep building up until this one shuts off the unit. This one's going to be at a much, much lower temperature because it's much farther away from the heat exchanger. So we want this guy to shut off at a lower temperature point so we know we're protected if we have any safety issues. So now we have all of our control board wiring separate, and everything's 2 wires, 2 wires, 2 wires, 2 wires to the limit. We have 2 wires to the inducer fan motor and back. We have 2 wires for our main power coming in, 2 wires to the primary of our transformer, 2 wires on the secondary of our transformer. Everything is 2 wires. Even our blower motor, which doesn't look like 2 wires, is still essentially 2 wires at a time. We have the 2 brown wires going to our capacitor, and between our speeds are going to be any 2 wires at a time. So it's going to be, for example, black and high speed and neutral, which is the white, or red wire, low speed and neutral, which is the white, or we would have blue medium speed with the neutral, which is white. So 2, 2, and 2 all the way around. If we take a look at this furnace, the fan for this furnace, there's a significant amount of dirt built up in this blower wheel. And that just happens over time, age of the system, but this unit probably hasn't been maintained or serviced very well, or it's in a very difficult location to pull the blower out. So if it's in a bad location, nobody wants to pull the blower out of the attic and take it down and clean it. But in this case, there's a significant amount of dirt inside of these blower wheels. We'll zoom in, see if you can see that. Here, I'll take and scratch this a little bit. You can see massive, massive amounts of dirt in that unit right there. So this wheel hasn't been cleaned before. You can also see on the sides of this unit tons and tons of dirt built up. So that's over many, many years of this thing running. This is our blower motor. Some of the things that we see about this motor is there's this little bit of a stain right here. We'll zoom in so you can see that a little bit better. This oil stain is because these are sealed bearings. They're sealed for the life of the unit. Over time, this oil starts to come out of the bearings, and that's what's causing the stain on here. So it's probably a matter of time before this blower went out anyways. We can also check the bearings, see how well the wheel moves. This wheel is moving pretty smooth, which is a good sign. Notice it's still spinning. Going to come to a nice slow stop. That's one thing we look for. We also look to see as we're turning this to make sure the blades are nice and smooth. Sometimes you'll see this thing wobble back and forth, and that's telling you you have an issue with your blower wheel. Another thing I want to look for is I grab the hub of this motor and I try to move it up and down to see if there's any play in it. And there's just a little bit of play in the bearings. Now forward and backwards, we don't really care about. So next, let's go ahead. We also talked about these components here in the burner to make it burn more efficiently. This is for NOx, or nitrogen oxide. In a place like California that has high amounts of pollution, this right here has helped distribute that flame and make it blend to where it's not having as much nitrogen oxide. If you're to convert this furnace over to propane, this particular model has a warning on a tag that says this piece must be removed. So we're just going to show you what that would look like. 2 screws, and this comes out. So you can see there's a significant amount of burnt on here, and probably this thing wasn't working right because there shouldn't be that much carbon built up on this component right there. But that's what that piece is. Next, what we're going to do is we're going to pull all of the screws out for this heat exchanger so we can pull the heat exchanger out of this unit and take a better look at it. Now that we have all the screws taken off from this furnace, I even took this top plate off so it's a little easier to get to. Comes off nice and easy. Now this is our heat exchanger. This is the heart of the entire system. So imagine if this was in a closet, you'd have to take all of these components off to get to this point. You could leave the blower section, but it's still a pretty good bit of work. Now you have to pull this out. And this is heaviest part of the system. So this is our heat exchanger. The air moves on this side of the heat exchanger, and the burners and hot gases, flames go through the inside of the heat exchanger. So there were 4 different burners. So we have 4 individual heat exchanger tubes. You can see here the main limit switch went in the center. And as I move this around, I can hear a significant amount of rust. So that means that probably one of these heat exchangers was rusted out. So what I'm going to do is take one of these apart and see if we can find a damaged spot in here. So here we can see our heat exchanger with that plate removed. And if we look up inside of this, there's a significant amount of dirt and rust. And here's something else that's interesting I found, is connected to that low nitrous oxide, nitrogen oxide, was some kind of a spring system originally on there, and that has burned completely out. So inside of these heat exchangers are in really, really bad shape. Let's show the light. In the top chamber of this heat exchanger, we can see lots of carbon built up, and we see these end pieces here. So there's definitely massive bits of rust in there. So this was a matter of time before it started leaking carbon monoxide. I didn't see an actual hole in any particular one of the tubes, but there's a lot of buildup inside. And notoriously, they're used to leaking right around these connections right here. So I don't see anything specific yet. As we turn this, but any one of these seams right through here, especially right here at the ends, are notorious for burning out, especially if the gas pressure wasn't set right. They'll overfire and burn out. We have some rust spots inside of there. We got some damaged spots here. What I'd really like to do is put my endoscope in there and see what it looks like on the inside, but it's so black and charred that it'd be really difficult to see. As I turn this upside down, you can see that tons and tons of rust and stuff just keep falling out of this furnace. You got to think that this is the material. This is what keeps the flames separate from the air in the house, and that's part of the heat exchanger itself, and it's just completely rusted up and in really, really bad shape. So it's a really good thing that they changed out this furnace, because it was done. Okay, so here's the tag of our unit, a lot of very important information. We'll have our model number, which should be recorded on every single service call. We'll have the serial number. The serial number is going to give us the age. And this particular brand, L94, this is a 1994 model furnace. So it's old, ready to be replaced. It has a manufacturer number, which is almost identical to the model number. In this case, it is identical. You want to make sure you write down any discrepancies between the model and the manufacturer number. This unit is manufactured for natural gas. It's designed for 100,000 BTUs per hour input rating. That's how we use to size the gas piping. However, it's an 80% furnace, so it's actually an 80,000 BTU output. So you always want to make sure you take your efficiency into account when you're sizing the output. If this furnace was replacing a less efficiency unit, you could easily oversize. The new furnace needs to be matched with its output as well. Otherwise, if I put a 90+ furnace in here, also 100,000 BTU, we'd be over by 20,000 BTU, and you never want to oversize a gas furnace or any air conditioning system. The manifold gas pressure, 3.5 inches of water column on the manifold side. And the minimum supply pressure input is 4.5 coming in, and a maximum of 14 inches water column coming in. So you have that range of pressure coming in. So if you have an issue to where your output is not getting high enough, check the input while other things are running, such as the stove or the water heater. Temperature rise, between 35 to 65 degree temperature rise. We're talking about the temperature of the air coming in can be then 35 to 65 degrees higher than the air coming out. It's also called delta T, the difference between air in and the air out. If the temperature rise is lower than 35 degrees difference between the air in and the air out, we're going to have a problem with complete combustion and soot building up in the heat exchanger. If we're higher than a 65 degree temperature rise, we're going to end up with the furnace overheating, and so we're going to have a limit trip. We're going to end up with damaging that heat exchanger. So this gives us a range between the input, between the temperature rise of the furnace. Now over here we have also a maximum air temperature outlet is 165. So if you're testing this unit in the middle of summer, firing the heat up, you want to make sure that your discharge temperature, air coming out, is no higher than 165 degrees Fahrenheit. That's going to be important because in the summer you still got to check these furnaces out. You just got to run them for a very short period of time, or maybe cool the house down first. So the amperage on this is maximum of 11.3 amps. So make sure we're not over amping any of this system. And it has an external static pressure of 0.15 inches of water column and 0.05 inches of water column for the blower. Both of these are direct drive blowers, same size. This one here is a different model number of 900 versus a 1020. So we got to match that up. On the other side of the furnace, we also have a data tag. This furnace is a horizontal, so this is the bottom side, and this is pretty dirty, pretty icky. If I try cleaning this, I'm afraid the numbers would wash off of it. But a lot of the same exact numbers as the other side. It does clarify 115 volts, 12 amps maximum, no more than 12 amps, 100,000 BTU input. The output is set for 79,000 BTU, so it's actually a little bit less than an 80% furnace, probably a 79% furnace, I guess, instead of an 80%. And over here we have our gas pressures in, manifold pressure, same information as before. The limit switch for operation is for fan on medium speed on the tap, and I can't really read too many of these other numbers. On the bottom side, if we look down a little bit lower, it has more information connected to closet installation. So if we're going to install this in a closet, it has to be 1 inch from the top of the furnace to the plenum, 6 inches from the front of the unit, 0 inches from the left and right side of the unit, 6 inches from the flue in any direction, 1 inch with type B1 vent. So it gives you specifications of how close you can be. Now your code, your city code, may have much longer, much farther distances. What you go with is whichever one is the farthest, whichever one's the safest. So if code says 1 inch and this was to say 5 inches, you'd have to be 5 inches away. If code said 5 inch and this said 1 inch, you'd still have to be 5 inches away. So whichever one's the farthest is the one that you have to go with. Tons of information in these furnaces. You have to RTFM, read the fabulous manual, and learn about these furnaces. This one was definitely an old furnace, but we've taken it all apart, learned about all the components, and we'll move on to our next video. Thanks for watching.